Welcome to this ultimate Regents chemistry review. We are checking out part B-1 of the January 2025 Regents exam. I already went over part A. If you check out here in the upper right-hand corner, I'm going to go ahead and put a link to that if you want to start from the beginning. It really doesn't matter where you start. Part A was all multiple choice, 30 questions, where you're relying on your knowledge of facts and definitions for different chemistry vocabulary. Here in part B1, now we're adding skills. I think that the test gets harder as you go along. Each of the parts, there are a total of 4 parts. B-1 is the second part, 20 multiple choice here. You have to score at least 50 points out of 85 possible points to just pass this Regents exam. You want to, again, maximize as much as you can. All right, with that, let's check out question 31. What is the approximate mass of an ion that has 12 protons, 13 neutrons, and 10 electrons? Now, ions are your charged atoms. That means protons don't equal electrons, but the mass of any atom or ion comes from the protons plus the neutrons. It doesn't mean electrons don't have mass, but it is so small, approximately 1/2000th the mass of a proton or a neutron, that we ignore it. So just take your 12, add 13 to it, and you get your answer of 25, or choice 3. For question 32, given the bright line spectrum of element X and the spectra of 4 mixtures, which mixture contains element X? Bright line spectra are the result of electrons for an atom going from the excited state and returning back to the ground state and releasing energy. And if that energy, of course, is in the form of light, we go ahead and we pick that up, and every element's atoms have their own signature, which when we bend the light, we get the bright line spectrum. Literally, all you're doing here is playing the matching game. Mixture A does not have element X in it right away. You can see this first line is not showing up in element X. We move to mixture B. Now, there can be extra lines, but we need to account for all 4 of these lines for element X in the mixture. And it looks to be that we have this first one from element X, the next 2, and then the 4th one. So right now, mixture B is looking like my answer. But you know what? Let's check out the other ones. Mixture C, again, I'm already missing the first line. It doesn't match up. And same thing with mixture D. So that makes our answer here, mixture B, or choice 2. For 33, we are looking at an electron configuration, and we're asked about the valence electrons for this atom in the ground state. Well, valence is your outermost electrons. Ground state means that the electrons are in the lowest energy levels available. When you read an electron configuration, you literally read it from left to right. That means that there are 3 electrons in the outermost level here because it's written 4th, and that is choice 3. Question 34, which statement describes the general trends in electronegativity and atomic radius as the first 7 elements in period 3 are considered in order of increasing atomic number? Now, you don't have to guess here. You have the periodic table and reference table S at your fingertips. We're going to use both of them here and be able to answer this knowing absolutely what the answer is. The first thing I want to show you, periods are your rows on the periodic table. We're starting with sodium, then magnesium as we're going across. Then we jump over to aluminum, silicon, etc. as we, again, just move from left to right. All we need to do is look up just a few of the elements, and we'll know what the general trend is That means we're going to reference table S. You can see very clearly here, I marked up the elements going across period 3, and I've also gone ahead and kind of circled, I guess it's more like a rectangle, the electronegativity values for those elements and the atomic radius. The electronegativities as we go across are increasing, and the atomic radius overall is decreasing. With that information, go back and answer the question. I know I mentioned this before in part A, but this is a two-part question. In other words, you're answering two different questions within this one question 34. With that information from reference table S, electronegativity is increasing, not decreasing, and the atomic radius is decreasing, which would be choice 3. Always have your reference tables out as you're working through questions yourself. Mark everything up. You can always print out new ones or ask your teacher for another set of reference tables. It's very important that you work with them and you also have your calculator handy. With that, let's go to 35. What is the chemical name for KClO2? I hope you can recognize, just looking at the formula, you have a metal in potassium, and then you have two nonmetals in chlorine and oxygen, which means there is a polyatomic ion here in this formula. So that's the first thing. You really just want to break apart the formula. It's not an organic molecule, it's a salt. So the first thing is we have the whole word for the metal, potassium. And unfortunately, that's the same here. That's not going to help us get to the answer. The next thing is, what is ClO2? The good news is you didn't have to memorize it. You just have to know where to look on the reference tables. And here it is, reference table E, selected polyatomic ions. Now we're looking for ClO2. And if we just go ahead and start from top to bottom, here it is as chlorite. When you have a polyatomic ion, you do not change the ending. You just go ahead and put it right in there. We're looking for potassium chlorite, which is choice 2. We finally get to a math question here, a real math question, not just adding a couple of numbers together. In question 36, what is the percent by mass of oxygen in CH3COOH? You have to know oxygen symbol is O, and if you don't know that, go to reference table S. All the names of the elements are there, so there's no excuse. Then you're dealing with percent by mass. Percent is the part over the whole thing times 100. Again, no excuse. Reference table T has the formula. On reference table T, here it is, percent composition, mass of the part, which is going to be the oxygen, divided by the mass of the whole, which means the entire compound, your gram formula mass times 100. They even give us the gram formula mass for the compound, so I don't even have to figure that out here. We have that it's 60, but I do need to add up the two masses for oxygen. Don't guess. Go to the periodic table and get the mass of oxygen and double it. And I would also recommend you write down numbers and things because it's so easy to make a mistake. You have 2 times 16 for your oxygen, which means you're going to have 32 divided by 60 times 100. And yes, to make absolutely sure you're doing it correctly, use your calculator. Your answer is 53%. For 37, given the formula for a compound, we're asked how many electrons are shared between the carbon atom and the oxygen atom in the molecule. Well, the carbon and oxygen. Each dash represents one bond, but the number of electrons being shared in a bond is 2. Since I have 2 bonds, 2 times 2, it's going to be 4. Question 38, we're looking at a particle model diagram, and we're representing particles in a sample of neon at STP. Neon is a noble gas. The symbol is Ne. If you didn't know that, you'd want to go and look at the periodic table. Remember, group 18 are all of your noble gases, starting with helium and then neon, Ne, is below that. Neon is what we call a monatomic gas, just like all the other noble gases. In other words, it doesn't have to couple up or be together to be stable in nature. And yes, it's a gas. So what are we going to do? We're going to show the atoms of neon farthest apart, which is choice 1. Question 39. The volume of a 150.0 gram sample of copper at 278 K, 101.3 kilopascals, is 16.7 centimeters cubed. The mass of the copper sample is expressed to how many significant figures? That means what holding places were involved in the measurement. We're talking mass, so we're talking grams. All you need to do is figure out how many significant figures are in 150.0. Since you have a number greater than 1 and you have a decimal point, they are all considered significant. So the total number of significant figures here is 4. For 40, which statement describes the energy transfer that occurs when a sample of copper at 100 degrees Celsius is placed in a sample of water at 20? We know that thermal energy, right, always goes from hot to cold. So with that, let's check this out. Now, it's not chemical energy because we don't have a reaction. We just have a physical process of copper going in the water. So right away, throw away choices 3 and 4. Thermal energy, again, transferred from the copper to the water, choice 1. Very interesting. The tale of 2 different questions. 41 is extremely easy. I think the question 40 was as well, and then we get to 42, which is going to be a little rougher. For 41, which change will cause an open flask, half filled with water? You're given a temperature and a pressure to reach phase equilibrium, right? Your phase equilibrium literally means liquid to gas, gas to liquid. And I think it's fairly straightforward and common sense. You'd have to seal the flask. It can't be open because then all the water molecules are just leaving the flask. Think about it when you leave a glass of water out at night. You come back the next morning and the water line, some of the water has quote unquote evaporated. Well, what's happened? It's gone into a gas and it's in the room. So same thing here. For 42 is not as easy. You're asked, what is the amount of heat released when 1 mole of ammonia is formed from its elements at 101.3 kilopascals? That was hard to say, and 298 K. You're not directed to the reference tables, but that's where you need to go. And we're dealing with heat. So we have to find where heat or thermal energy is being listed, and we're forming ammonia. Let's check it out. Here we are at table I, labeled heats of reaction, and we're looking for the formation of ammonia. And we have to scroll down here, and lo and behold, here it is, 2NH3 gas. Now, we also have to be careful because in this balanced equation, we are forming 2 moles of ammonia for 1 mole of nitrogen and 3 moles of hydrogen. And the amount of energy being released is 91.8. The negative sign tells me it's exothermic, and actually at the bottom of this table, you're told the negative sign means that it's exothermic or being released. But the question is, am I using the 91.8 in total, or do I have to divide it by 2 for every 1 mole of ammonia? So let's go back to the question. And sure enough, look at what it's asking, 1 mole of ammonia. Reference table I shows it for 2 moles. I got to take my 91.8 and divide by 2, and I'm actually putting it in the calculator to make absolutely sure, and the answer is choice 1. I'd say right now, from parts A and B-1, 42 was the hardest question. For question 43, given the equation representing a phase change for carbon dioxide, which statement describes this phase change in terms of energy and entropy? So both. Sorry for my bad circling of those. Well, let's take them one at a time. You see energy here on the left-hand side of the equation as a reactant. That means we're putting energy in. Putting energy in is endothermic. If energy was showing up here as a product, that would be exothermic. So the first part of this is the phase changes endothermic, and I'm going to get rid of 3 and 4. All right. Then I got to deal with my entropy. Entropy is the amount of disorder or randomness, or this new terminology they're using in AP Chem of microstates. In other words, how ready are the molecules to react with something else? And certainly when you have molecules in the gas phase, they're far enough apart from one another already that for them to react is going to be easier than if they were a liquid or a solid. Okay, so when I'm going from a solid to a gas, the phase changes, or the phase change here, is definitely an increase in entropy, and that makes it choice 1. Moving on to question 44, which equation represents an oxidation half reaction? Now we're in electrochemistry. Oxidation means losing electrons. You have a substance losing electrons. You might have heard your teacher say Leo goes grr, I'm sure. Loss of electrons is oxidation. All right. If I'm losing electrons, electrons need to be showing up on the right-hand side here. And you might hear some bells in the background, and that's my dog playing around with bells. Sorry about that. It can't be, in other words, then choice 2 or choice 3, because there are no electrons on the right-hand side. And now we want to make sure that since this is a half reaction, that we're balanced in terms of mass and charge. For choice 1, I have the bromine here, Br2, right? 0 charge. But on the right-hand side, I have a -2 and 2 electrons for a total of -4. That is not balanced in terms of charge. It can't be choice 1 either. The only choice that makes sense is choice 4. I have manganese becoming a manganese 2+ ion and losing 2 electrons. Question 45, which equation represents a redox reaction, reduction and oxidation? That's taking place within the atoms as far as losing and gaining electrons. Now, the simple answer is look for an element or elements that are alone on one side of the arrow and bonded together on another. That's your answer. And the reason being is when you have an individual element that hasn't lost or gained electrons, the oxidation number is 0. Even your diatomics, your oxidation number is 0. Yet when they're bonding, they're either losing, gaining electrons, transferring electrons, sharing electrons, but not sharing them equally. So these other 3 equations, nothing is changing as far as the oxidation number or the number of electrons. Your answer here, choice 1. 5 more questions to go here in this part with 46. Based on table J, which metal will react spontaneously with the iron 2+ ions? And we're given copper, gold, magnesium, and silver. Let's check out table J. Okay, so table J, you have a column for metals and a column for nonmetals. Your most active metals means that lithium here, as the first element, wants to lose electrons the most. All the other elements are below it as far as order of losing electrons. And then for nonmetals, it works the opposite way. Fluorine wants to gain electrons the most, and then as you go down, it gets less and less. We were looking at what is going to react with iron spontaneously. And actually, I misspoke. It wasn't iron as in atoms, it was iron ions. So iron has already lost a couple of electrons. Well, what wants to lose electrons more? It's going to be all of these metals above iron. All the ones below, if you take any of those metals and you throw it in a solution that contains iron atoms, nothing's going to happen because iron wants to lose its electrons more than anything below it. You're still not sure what in the heck I'm talking about. It is extremely simple. You literally, and I'm going to just move this down so you get all four choices here. You go ahead and you circle iron, and then the four choices. Now, typical Regents question, they give you the names of the elements, not the symbols, but what do we have here on table J? Just the symbols. If you don't know the symbol or any of the choices, look it up on reference table S. You have copper, which is Cu. You have gold, which is Au. You have silver, which is Ag, and then only one above, which is magnesium. There is your answer. Magnesium atoms want to lose electrons more than iron atoms. So therefore, if you have a solution with iron ions, magnesium will lose its electrons and give those electrons back to the iron ions. That makes the answer for question 46, choice 3. For 47, we're going back to the reference tables, table F, a saturated solution of which compound is the best conductor of electricity. Your conductors of electricity are your metals, which are all solids except for mercury, which is a liquid metal, and then your soluble salts, your strong acids, and your strong bases. Here, you're talking about four choices for salts, and we're looking for what is soluble in water, because then it splits apart into ions, and when you have moving charges, you have a conductor of electricity. Now, this is definitely the wonkiest table New York State provides as far as the reference tables go, in my opinion. You have four salts that you're trying to figure out which one is soluble, and the other four are going to be insoluble. And the way you read this chart, the first column is soluble. Exceptions mean that these are insoluble. Then you have insoluble, and then these exceptions are soluble. And you're literally going to take each of the four formulas and split it in half, your metal and your non-metal or metals, right, your poly, and figure out by process of elimination, just reading the table, right, whether it's soluble or insoluble. So the first example is calcium carbonate. I'm just going to draw a line. Calcium's +2 as an ion, carbonate is a -2. I'm looking for one of these two or both. So I'm going to start with calcium +2. I don't see it in this first column. I do see it here as an exception, but that's with sulfate, and I'm with carbonate, CO3. We're going to keep moving. Oh, look, carbonate ions or compounds that have carbonate in them are typically insoluble, except when combined with a group 1 ion or ammonia. Well, guess what? Calcium is not group 1, it's group 2. That makes this compound insoluble in water. In other words, you throw it in there and it just falls to the bottom. The next one is barium sulfate, or BaSO4. Now, the first column is showing that sulfate compounds are typically soluble, but look at the exceptions. And sure enough, there's barium. This is not the answer either. Then choice 3 was magnesium hydroxide, MgOH parentheses 2. I don't see Mg here. I don't see Mg here. I don't see it here, and I don't see it here. Great. Let's go to the OH minus. I don't see it in the first column or the second column, but sure enough, here it is. It's typically insoluble, except for these exceptions, which magnesium is not. Sure enough, insoluble compound. That leaves the very last one, which is your sodium nitrate or your NaNO3. That is soluble in water. In fact, all group 1 ions, there are no exceptions, soluble in water. And for that part, all of your nitrate compounds, so compounds that include nitrate, are also soluble in water. That is your answer. Choice 4. Moving on to 48 here. Given the equation representing a system at equilibrium according to one acid-base theory. Well, there are two theories for acids and bases. One is an acid has H plus as the positive ion, and a base has OH minus. And the other has to do with what is donating H plus and what is accepting H plus. It's actually known as the Bronsted-Lowry theory. I don't know why New York State had decided a long time ago now not to mention Bronsted and Lowry, but they don't. So what we're looking for is the Bronsted-Lowry or other acid-base theory, where an acid will donate or give up an H plus and a base will accept it. Before we get to the choices, let's label the equation. Now, you have two things or two reactants you're starting with in two products, right? And what you end up with is whatever you start with and whatever you end with, the only difference is going to be an H plus. I can't hook up HSO3 minus with H3O plus. Where did the sulfur go? So the combo here, or better known as a conjugate pair, is between the HSO3 minus and the SO32 minus. What's the difference between the two? Well, guess what? The H plus has been donated. Well, where did it go? It had to go to the H2O. H2O went to H3O plus, and we added an H plus. So the H plus from HSO3 went to H2O to make H3O plus. Let's take a look at the choices now. So HSO3 is acting as an acid. That is correct, because it is an H plus donor. It is not acting as an acid. It is not accepting. Water is not acting as an acid because it's not an H plus donor in this equation. And it can't also be acting as an acid if it's an H plus acceptor. That's not the case. So the only answer that makes sense here is choice 1. Final two questions here in 49. What is the pH value of an aqueous solution with a hydronium ion concentration 1,000 times greater than an aqueous solution with a pH value of 5? As your hydronium ion concentration increases, it means your acidity increases, but that means your pH value decreases. If I'm going from a pH of 5 down to a pH of 4, that is a 10 times increase in H plus. If I'm going from 4 to 3, that's another 10 times, and 10 times 10 is 100. And then if I'm going from 3 to 2, that is another 10 times, and 10 times 10 times 10 is 1,000. And there's our answer. For question 50, which energy source is paired with a risk associated with its usage? Well, we're back to a fact here for question 50 to end part B-1. Choice 1, nuclear fission produces stable isotopes. That is not the case. Nuclear fission produces radioactive waste. That is a risk. And there is our answer. Voltaic cells produce stable isotopes. That's not the case. When you're talking isotopes, you're talking nuclear chemistry, not reduction oxidation, and voltaic cells do not produce radioactive waste. So the only answer can be here for question 50 is choice 2. I hope you got something out of this. I hope you're working on questions on your own and then coming back and checking out answers. I have plenty of videos to get you ready for the Chem Regents exam, and I hope you take advantage of those. No matter what, good luck. I will be posting the other two parts of this exam shortly. And with that, have a great day.